Assalamualaikum warahmatullahi wabarakatuh and hi everyone. So in this video we are going to continue on the second subtopic of this chapter 2, that is charging and discharging of capacitors, and we will look at the physical meaning of time constant, and you will use it during your tutorial session. We will look at the sketch and explain the characteristics of QT graph and IT graph for charging and discharging of a capacitor, and you will use these two equations of charging and discharging in your tutorial class. So as we know that capacitors store charge, so it can undergo two different processes, that is charging and also discharging. So the charging process occurs when we have a circuit and this circuit is complete when the switch S is closed, and immediately the current of I0 will begin to flow through the circuit. And once the current flow, the electrons will start to flow out from the negative terminal of the battery and accumulate on the plate B of the capacitor, as you can see on the plate B. And then the electrons will flow into the positive terminal of the battery through the resistor R, leaving a positive charges on the plate A. As charges accumulate on the capacitor, the potential difference across it increases. So when the charge already accumulate at the capacitor, the potential difference at the capacitor itself will increase, and the current is reduced until eventually the maximum voltage across the capacitor equals the voltage supplied by the battery. At this time, meaning when the capacitor is fully charged, the potential difference increases up to a maximum voltage, where the maximum voltage will equal to the voltage at the battery. So current will decrease at this time. So at this time, no further current is flow through the resistor R, and the charge Q on the capacitor thus increases gradually and reaches a maximum value of Q0. So let's look at the graph that explains this. As we are charging the capacitor, the charge for the QT graph, the charge on the capacitor will increases with time. So we can see here it is increasing exponentially, and it will reach to one point of Q0 when our capacitor have reached a maximum potential difference, and the current will be zero. There is no current flow, and so we will have a increasing of graph of the QT graph, and this gives us a charging equation, which is Q equals to Q0 bracket 1 minus exponential negative T over RC. And this is the equation of charging of a capacitor. And for a potential difference against time graph, it will also increases with time. As the capacitor accumulating all the charges, over time the potential difference will also increases, and so we will have the equation of charging capacitor for potential difference as V equals to V0 bracket 1 minus exponential negative T over RC. And as the charge and potential difference increases, the current will be decreases up to no current flow when the potential difference is maximum. So the graph that represents the current for a charging process is decreasing over time. And we have it as I equals to I naught exponential negative t over RC. And it is decreasing over time as the capacitor is charging up to a maximum potential difference. Let's look at the discharging of a capacitor through a resistor. So a discharging process is a reverse process from the charging of a capacitor. So when we close the switch S, electrons from the plate B begin to flow through the resistor R and neutralizes positive charges at plate A. So initially the capacitor is fully charged. So when we disconnect the switch, the electron from the B part, from the plate B, it will go through resistor R and neutralizes the positive charges at plate B. So initially we have the potential difference across the capacitor as maximum, and now a maximum current will flow through the resistor. When part of the positive charges on plate A is neutralized by the electrons, the voltage across the capacitor will reduce, and this is why the current will start to increase to its maximum. So the process continues until the current through the resistor is zero. At this moment, all the charges at plate A is fully neutralized and the voltage across the capacitor become zero. So it is completely discharged when all the charges at plate A is fully neutralized. So we can see we can represent it as a graph of QT graph, where the charge on the capacitor decrease exponentially with time, because this is a discharging process. So across time, the charge from the capacitor will decrease. It is similar to our phone. Sometimes we have to charge our phone when it is decreasing its battery. So we have to charge. And once we disconnect it from the plug, it started to discharge as we use the phone across time. And the equation for a discharging, and also the current through the resistor decreases exponentially with time. This is across the resistor. Okay, it is not the current through the capacitor, but the current through the resistor decreases. And the voltage across the capacitor will decrease exponentially with time. And we will get the equation of discharging as Q equals to Q naught exponential negative T over RC, similarly to voltage and also current. So now let's look at the time constant that we have looked in the graph that we have both in charging and discharging. So time constant is called tau. The symbol is for tau. Is the quantity of RC that appears in the exponent for all equations in the charging and discharging process. So this is the physical meaning of it. It appears in both charging and discharging process. So the equation tau is equals to RC. Tau is directly proportional to R and also C, the capacitance. So the unit is seconds. It is similar to the time. It is a measure of how quickly the capacitor charges or discharges. So this is the physical meaning for time constant in the case of charging and also discharging. So let's look at the example. So in this RC circuit shown in figure 2.6, the battery has fully charged the capacitor. At time equals to t0 second, a switch S is thrown from position A to B. Initially, it is being charged, and then the switch changed from position A to position B. And the battery voltage V0 is 12 volt and the capacitance C as 3 microfarad. The current I is observed to decrease to 0.45 of its initial value in 60 microseconds. So determine the value of R, which is the resistance of the resistor. So we will apply as the switch is closed at position A, the capacitor in the circuit is being charged. And then when it is changing its position to B, the capacitor will start to discharge. So we will apply the equation for current for discharging process. That is I equals to I naught exponential negative T over RC. And because the current is observed to decrease to 0.5 of its initial value, so the current after the final current is 0.45 of its initial equals to I initial exponential negative the value of T over RC, and substitute in all the values and we will get our value for R. And mathematically solve, we will get R as 25 ohm. And the time constant for the question B, the time constant is given by tau equals to RC, and we already found our R, so we substitute in R with the given capacitance and we will get our time constant. And the discharging value, the value of Q when the charge on the capacitor at T equals to 0, we will also use the discharging process and we will find our value of Q at time equals to 0. And from this equation, when we substitute in T as 0, we will left with Q equals to Q naught, because exponential of 0 is equals to 1. And finally, we will have left with Q naught, Q equals to Q naught, and Q naught is equals to CV naught. And we can find Q by substituting the value of C, the capacitance, and also V naught, which is 12 volt, and we will get the value of Q. And to get the value of Q for the given time, which is 100 microsecond, we will also use the equation for discharging process and substitute in the value of the given time, which is 100 microsecond, and we will get our value of Q, which is 9.49 times 10 to the power of negative 6 coulomb. And that's all for this video. Thank you for listening, and we will continue for subtopic 2.3 in the next video.